2.3 million blocks, 6 million tons of limestone, a project timeline spanning 27 years. Most see a monument to a god king. I see a massive capital expenditure project with a margin for error that would bankrupt a modern multinational. If you think this was achieved through trial and error, your project management perspective is fundamentally flawed. In high-stakes engineering, trial and error is simply another word for systemic bankruptcy. Now, let's peel back the mythology and verify the receipts. It's time to audit the operating system of this civilization. We begin our audit at the foundation. The invoice for Project Giza 01 begins with the leveling of the natural bedrock. This is the critical path. Before a single block is quarried, the site must be prepared to a tolerance that rivals modern laser-leveled skyscraper foundations. The scope is 13 acres. To the untrained eye, a 1 centimeter leveling error across 230 meters seems negligible. To an auditor, it is a technical debt that compounds exponentially. If the base is not perfectly horizontal, the center of gravity shifts. As the structure rises 146 meters into the atmosphere, that 1 centimeter deviation translates into a structural drift. That prevents the four faces from meeting at a single apex point. You don't get a pyramid. You get a 6 million ton pile of rubble and a failed ROI? This wasn't a choice. It was a non-negotiable engineering mandate. To understand the 1 centimeter precision, we must audit the resource allocation dedicated to the leveling phase. The standard archaeological narrative suggests a grid of water-filled trenches. From a project management perspective, this is a brilliant use of a self-leveling liquid as a baseline. But the audit reveals a deeper complexity. The receipts for this phase aren't just in the tools. They are in the procurement logs. We reference the Diary of Mir, an inspector-level logbook from the 27th year of Khufu's reign. Mir wasn't a priest or a dreamer, he was a logistics manager. His receipts track the movement of high-quality Tora limestone, the casing of our system from the quarries across the Nile to Giza. Mir's crew of 200 men moved 30 blocks every 10 days. This is our supply chain throughput. If the leveling was off by even a fraction of a degree, these precision-cut blocks from Tora would arrive on-site and fail to fit the critical path. Any discrepancy in the foundation would require on-site retooling, creating a massive supply chain bottleneck in a project of this scale. Custom fitting to 0.3 million blocks is a death sentence. For the timeline, the precision of the foundation was the only way to ensure the interchangeability of parts across a 20-year build cycle. Now, let's audit the human hardware. We aren't looking at slaves. We are looking at a highly optimized labor force. To maintain this level of precision, the workers required a specific caloric ROI. Our audit of the workers' village at Giza reveals the fuel receipts: thousands of cattle, sheep, and goats slaughtered daily to provide high-protein rations. Total labor force: approximately 20,000 specialists. Average daily intake: 3,500 to 4,000 calories. Total system fuel: 80 million kilocalories per day. If the logistics infrastructure, the bakeries, the breweries, and the grain silos failed to deliver for even 48 hours, the cognitive fatigue of the workforce would lead to errors. A tired surveyor misses a 5 mm deviation. A 5 mm deviation at the base, compounded over 200 layers of stone, results in a structural twist that would cause the pyramid's apex to miss its mark by meters. This is the technical debt of Giza. Every centimeter of error at the foundation is a debt that must be paid back with interest. As the building rises, the fact that the Great Pyramid is nearly perfectly aligned to true north within 3/60ths of a degree proves that the Quality Control QC department had absolute authority over the production line. The ancient managers were running a real-time data overlay on the physical world. They weren't building for eternity. They were managing a zero-tolerance system where failure meant the total collapse of the state's most expensive asset. The audit is conclusive. The 1 centimeter leveling tolerance was not a feat of ancient magic. It was a calculated risk mitigation strategy. In the world of high-stakes construction, we call this front-end loading. By investing heavily in the foundation's precision, the managers of Project Giza 01 ensured that every subsequent layer of the supply chain from the quarrying in Tura to the transport logs of Mira remained aligned with the critical path. The return on investment ROI for this 1 centimeter precision was the survival of the 4th dynasty's political and economic capital. Had the foundation drifted by even 50 millimeters, the structural load-bearing capacity of the internal chambers, including the King's Chamber and its massive granite stress-relieving beams, would have been compromised. We would be auditing a catastrophic structural collapse rather than a standing monument. From a technical debt perspective, the Giza Plateau represents the ultimate clean code of ancient engineering. They refuse to pass errors downstream. They address the most difficult engineering hurdle, the horizontal baseline, at the very start of the project lifecycle. This is the hallmark of a mature civilization operating system. While other civilizations built until their structures failed under their own weight, the Giza architects managed the physics of gravity through the management of data. The miracle of the pyramids is a myth created by those who do not understand logistics. The reality is far more impressive. It is a 500-year-old receipt for a project that was managed to a zero-tolerance standard. If you wish to review the full audit report on the Giza Foundation, the file is available in the playlist.